Hello everyone, this is Heading Tian. In this video, let's learn chapter 8.2, Graphs of Polar Equations. We will learn three objectives. The first one, let's graph polar equations by plotting points. In the example, if we have a equation R equals 6 times sine theta, that's the polar system equation. That means we need to graph it in the polar system. So we need to find the point. First, make a table that theta is on the first row and then R on the in the second row. Theta, first point, I can choose theta equals 0. That means 0 degrees. And then some special angles, pi over 6, pi over 4, and their R's value. So if I plug in theta equals 0, so 6 times sine 0 is 0, so R is 0. If I plug in theta equals pi over 6, 6 times sine pi over 6, that's 6 times 1/2, that's 3. And then plug in pi over 4 in the equation. R equals 6 times square root of 2 over 2. That's 3 times square root of 2. And then we know square root of 2 equals 1. It's about 1.41. So 3 times 1.41, that's about 4.2. Keep one decimal place. And then continually, we find the R's value by the special angles. And then from 0 to 2 pi, that's one full cycle. And then we can plot the point on the polar system. So the first point is 0, 0, because we have learned the point is R theta. That means R is, since R here is 0 and theta is 0 is here. And then second point is pi over 6, R is 3. So pi over 6, that means this angle is pi over 6. And then the distance from the pole or origin to here is 3. So we plot this point. And then pi over 4, and this is 3 times square root of 2. I can plot the R's value is 4.2. And so the angle from initial to here, that's pi over 4, that's 45. And distance from here to here is 4.2. And then next point is pi over 3. And the R's value, we can plot 5.2. That means the angle from here to here is pi over 3. Distance from here to here is 5.2. And then continually, we can plot all of these points on the graph. Then I got a shape like a circle. So this is a graph for R equals 6 times sine theta. So this is how we plot the point and find the graph. And when you are working on your homework, so you need to plot 6 points. So you can just insert 0.3, pi over 6, 4.2, pi over 4, and 5.2, pi over 3. So continually you got 6 points. Then you can use a curve to line them up. Then we got a circle. So let's see, R equals 6 times sine theta can be converted to rectangular form. Yes, for sure. Look at the graph, it is a circle. So in the XY plane, that's the rectangular form. We can convert the R equals 6 times sine theta to the XY expression. So how to do it? Do you still remember last video we have learned that we can multiply by R both sides. So R times R equals R times 6 times sine theta. So R squared equals 6 times R sine theta. Do you remember R is x squared plus y squared? And then 6 times R times sine theta, that's y, equals 6y. So I can move the 6y to another side. X squared plus y squared minus 6y equals 0. When you see this kind of form, that's a circle. So if I want to complete a square, I need to add something. Add what? X squared plus y squared minus 6y. Add a number that 6 divided by 2 and square it. Add a number that equals 6 divided by 2, that's 3, squared. Equals, since this side I add a 3 squared, another side I also need to add a 3 squared. So x squared plus y minus 3 squared equals 3 squared. This is a circle because the circle, the center of the circle is 0, 3, because let this one equal 0, because before we have learned that something in the parentheses of the x equals 0, so x is 0, and let this part equal 0, so the y equals 3, so this is the center, so 0, 3, this is the center, and so this side is r squared. That means r is 3. That means from here to here is, we already learned this is 3. The distance from here to here is 3. That means this is the center and this is a radius 3. I can draw a circle. So this is a circle exactly the same like this one. So we use the rectangular form represent the r equals 6 times sine theta. The expression is this. Also, if you give me this, it's okay, but you better give me this form to provide us the graph of the circle. By this expression, it's easier to find, to express this circle. Okay, let's see next one. Test the polar equation for symmetry. So in the polar system, so we have learned that this is theta, this distance from here to this point is r. If symmetry with respect to the polar axis. What is polar axis? This is polar axis. We call it polar axis. Before we have learned the xy plane, we say this is x plane, x-axis. But here we say this is polar axis. And this vertical line we called theta equals pi over 2. Why? Because from here to here, is that a pi over 2? Theta equal pi over 2. So we call this line is theta equals pi over 2. And then we call this is origin, or we say this is pole. If the point is symmetric to the polar axis, that means the polar axis is like a mirror. So this point has another point here, is symmetric to this line. So if I have an equation or a function in the polar system, and I say the graph is symmetric to polar axis, so the graph may be like this, for example. So it's symmetric to this, that means it's like this. Should be like the heart is like this. So it's symmetric to the polar axis. That means I have a point here, for example, this point is r theta, and then another point here is r negative theta. Why? Because the distance from here to here must be r. Distance from here to here is r. But the angle, so for this theta is from initial to this terminal. So I just draw a dash line. So it's from initial to this terminal. This is theta. And the point here is this initial to this terminal is negative theta. So this one and this one, the absolute value is equal, but one is counterclockwise, one is clockwise. That's different rotation. That means here must be negative angle. That's negative theta. So they provide you if the point is symmetric to the polar axis, that means another point on another side of polar axis is r negative theta, because from here to here is theta, from here to here is negative theta. So if the equation with a symmetry with respect to the line theta equals pi over 2. So if 2 points on the equation, one is here, one is here. So if this this function as a symmetry with respect to the line theta equals pi over 2, that means this one theta equals pi over 2 is like a mirror. So this point, they should be here and here, and they have the same r because the distance from here to here is a different. The only difference is the theta. For this point, the theta is from initial to this terminal is theta. And here is from initial to this point. So what is the angle for this pink one? So from here to here. So we have learned this is theta. So the reference angle of this angle must be theta 2. I mean the reference angle. That means from here to here is pi minus theta. So that means if this function or this equation is symmetry with respect to the line theta equals pi over 2, that means I may have this kind of graph. And then if this is symmetric to the theta equals pi over 2, I must have a shape like this. Assume they are symmetric, so it's not symmetric. Try draw a better graph. Okay, just imagine that it's symmetric. And then symmetry with respect to the pole. What's the meaning of that? Do you still remember that I mentioned about reflection things? So if a point is respect to the pole, that means, or if a function, for example, what kind of function? For example, a circle, very simple one. Imagine this is a circle, and then I reflect this circle to the this right now. This is a polar axis. Polar axis. So upside down, I got the same graph, and then this one I reflected along this theta equals pi over 2. So I do the reflection. So I got the same image. That means this circle is respect to the pole. So that means I flip it twice. First time I can flip it along the polar axis. Second time, flip along the theta equals pi over 2. So flip twice. Or you first time do the flippation along the theta equals pi over 2, and second time do the polar axis. So it doesn't matter, just remember flip twice. So this graph still keep the same. That means is symmetry with respect to the pole. And let's see this point. If I have a point here, so for example, this is a point. This is P. It's R theta. So theta is here, and R is from here to here is R. And symmetry with respect to the pole, that means after reflection, 2 times reflection. Do you remember the first time reflected? Maybe I can reflect it to here, because reflect, do the flip along the polar axis from here. I got here, and then flip along the theta equals pi over 2. I got here. So that means here, jump to the here, and then that means symmetry with respect to the pole, because I flip it twice and got here. And then this point is negative R theta. Why? Look at this. Is the distance changed from here to here, from here to here? Yes, because before is the direction of the R is from here to here, but now I change the direction. It's from here to here. And then, so if I have the R theta, the point here, and I don't change theta at all, just keep the theta. So R theta is like this. How about negative R? That means the R changed the direction. So draw this first. So negative R, that means going to another direction, backward. So I got negative R theta. So this Q point is negative R theta. Can I use another expression to express the point Q? Yes, of course. If I have a positive R, that means, for example, I just say this R is positive. From 0 to here is R is positive, and I want to find the Q point. So R is here, but the theta is never theta, because I want to go to Q point. From here, I need to do the rotation, the counterclockwise pi unit. That means theta plus pi. I got here. Can I do theta minus pi? Yes. The clockwise theta minus pi, I got here again. That means this Q point also equals to a positive R, comma, theta plus pi, or R theta minus pi. So I have 3 expressions to express Q. So does it make sense for you? Okay, let's move on. Test for symmetry in polar coordinate. We have learned 3 kinds of symmetry. So if I have an equation, and the first step, if a symmetry with respect to the polar axis, so I can replace the point R theta by R negative theta. So look at here. So if my function is symmetric to the polar axis, so replace the R theta by R negative theta. And then let's see if the equation is still keep the same. That means it's symmetric to the polar axis. And next one, symmetry with respect to the line theta equals pi over 2. Replace R theta by R pi minus theta. So it's the same like this. That means if I have a equation, and then I plug in my equation by R pi minus theta, before is R theta. Right now, I replace R and pi minus theta. If the equation keep the same form, that means it's symmetry with respect to the line theta equals pi over 2. And next step, symmetry with respect to the pole. Replace R theta by negative R theta. It's the same thing like this in the image. So you can also replace the R theta by R theta plus pi, or r theta minus pi. So if here, you can replace by the positive r. So theta plus or minus pi. You can do either one. So note, 3 tests are inconclusive. If we prove the graph is symmetric, then it's symmetric. However, some symmetric graph can't be proved by the test. That means by the test, if we can prove this this graph is symmetric, so that must be the symmetric. But sometimes we can't prove the graph is symmetric. For example, if we use the, for example, second one to prove is respect to the line theta equals pi over 2. So if we replace the r theta by r pi minus theta, the equation is not like the previous form. That means the test is inconclusive. I can't say for sure that this graph is not symmetric with to the line theta equals pi over 2. We say it's inconclusive to prove this is symmetric. So we will talk about this in the following questions, examples. So if we can prove it's symmetric, it must be symmetric. If we can't prove it's symmetric, we say it's inconclusive. We can't say it's not symmetric. So for example, number 3, if we proved that the equation by number three, the original function, if I plug in r theta in the equation, so equation, for example, r equals something, and then I plug in the negative r theta in that equation, and then this one is not equal this one. That means the test is inconclusive. Test is inconclusive. You can't say it's not symmetric to the pole because we don't have sufficient things to prove is not symmetric. We can just say the test is inconclusive. So let's see graph R equals 4 times cosine theta test symmetry. So before we plot the points, and then right now we can use we can test the symmetry first, because by the symmetry we can plot the last point. So first, let's test the symmetry. Let's try to test is symmetric to the polar axis. So replace the r theta by r negative theta. So r equals 4 times cosine negative theta. I know cosine theta is the even function. That means this equals 4 times cosine theta. So the original equation equals the equation we have found. That means it's symmetric to polar axis. Okay. And then let's see, is that symmetric to the theta equals pi over 2? So I can plug in, we can plug in r pi minus theta, because just go back to the previous slide and to see why I plug in r pi minus theta. This one, plug in r negative theta. So is this one equals this one? Let's see. So 4 times, so we can expand this, cosine pi times cosine theta plus sine pi sine theta, and come to this place. So 4 times, so what is the cosine pi? So cosine pi is -1. We have cosine, negative cosine theta. And this part, sine pi is 0. So 0 times sine theta is 0. So this one equals -4 times cosine theta. So r equals -4 times cosine theta is not the same form like r equals 4 times cosine theta. So I should say the test is inconclusive. So I just write inconclusive like this. A point. Okay, third, let's see, is symmetric to the pole. So what I should plug in? -r theta. So -r equals, if I plug in this equation, I have -r times equals 4 times cosine theta. So are they the same? This one and this one same? No, they are not same. So this test is inconclusive. That means it's symmetric to the polar axis. That means the graph maybe looks like this. For example, like this. So it's symmetric to the polar axis. So this one, like a mirror, is symmetric this side and this side. So I just need to graph half. Just plot the point or half, and then I don't need to find the other half because it's symmetric. So here, so let's see, we still need to find the points, but not too many like the previous one. Let's draw the table. So the first row, I can write the theta. Second row, I write the r. So when theta equals 0, so cosine 0 is 1. 4 times 1 is 4. And then pi over 3. Oh, sorry, pi over 6. Pi over 6, cosine pi over 6, that's square root of 3 over 2. So 4 times square root of 3 over 2, that's 2 times square root of 3. And pi over 4, that's cosine pi over 4 is square root of 2 over 2. That's 2 square root of 2. And then, so pi over 3. Pi over 3 is what? It's 1/2. Cosine pi over 3 is 1/2. 4 times 1/2, that's 2. And then continually, we can plug in pi over 2. So pi over 2, so cosine pi over 2, cosine 90 degrees is 0. So 4 times 0 is 0. Is that right? Yes. So I can continue to plot the point, but actually it's not necessary because it's symmetric to the polar axis. That means the first point, clear this one, I draw a better graph. So the first point is 0, 4. That means the angle is 0, but the length from here to here is 4. And then second one, the angle is like this, is 30 degrees. And then the height, I mean, not the height, the distance from this point is 2 times square root of 3. And then next point is pi over 4, angle is like this. And then the distance is 2 times square root of 2. And then because next point is 60, is about here, is 2. It's 2. So from here to here is 2. And then next point is power 2, 0 is here. So the graph is like this. So how about another part? I'd better to use the negative theta because that means I plug in negative theta, I have the same R, correct? That means I can just make it short. Negative pi over 6, plug in the negative theta, the same R's value, 2 square root 3. And the negative pi over 4, I got the positive 2 square root 2. And the negative pi over 3, and I got 2. Be careful, these are distance. So that means it's symmetric. So negative pi over 6 is here 0. Go this one. And then here is the distance from here to this point is 2 times square root 3. So this point. And then this is this point. And this one is the point here. So line them up. Sorry. Okay. So this is a circle. Let me line them up. I got a circle. Its center is here. So what's the meaning of this? So you're gonna have the same question in your homework. So this one you can just they ask you plot 4 points. Oh, so sorry, I think 6 points. You can just plot 0, 4, 0 because R theta. So you just plug in 4, 0, 2 square root 3 pi over 4. Oh, pi over 6. And this one, and this one. Just pick 6 points and then line them up like a circle. Or you just click circle, and then center is 2 because from here to here is 4. Center should be here. The distance from here to here is 4. The radius is 2. Okay, let's move on. I'm not sure I should make the. If I have time, I think I can do an example. Let's see if I have the similar question. Oh, I think this one is good one. Is that a similar? It's very similar. So this one you can just for example, this one you can plot 6 points. So click here and then put the R here, theta here, and then plot the point. And then you need to plot second point. So put R here, theta here, and then plot the point. And then you plot 6 point, then you check your answer. So you will get a beautiful circle. So for this one, this is a circle. It's like this. Oh, I can't draw. So the circle is like this. The radius is 3.5. Okay, let's see. Next question. Graph theta equals pi over 4 test the symmetry. So I think this one is very easy because when think about this, it just provided you the theta. It doesn't have the R in the equation. That means the theta, this angle is pi over 4, that's 45 degrees. And if it doesn't mention about the R, that means any R works for me. So R can be here, can be here. So R can be here, can be negative. So everything on this diagonal line. So this is the diagonal line. And test the symmetry. Do I need to go back to use these 3 tests? I think there's no necessary to use the 3 tests because just from the graph, I know if I I just flip this along the polar axis. I got this graph. So you see, so this graph and this line and this one, they don't overlap. That means it's not symmetric to the polar axis. And then if I do the reflection along the theta equals pi over 2. So if this is a mirror, I have another one like this. So they don't overlap. That means it's not symmetric to the theta equals pi over 2. So how about the pole, the origin? So if first I flip this one along the theta equals pi over 2. So I got this. And then flip again along the polar axis. So I flip this one along this. I got this line. That means this line overlapped by the two reflections along this one and this one, and this graph looks like the same like the original one. That means this graph is symmetric to the pole. So you don't need to use 3 tests to test the symmetry. So just reflect it twice to see if it's symmetric to the pole or symmetric to the, I think you understand what do I mean. Okay, next example. So r squared equals 16 times cosine 2 alpha, test the symmetry. So it doesn't let you to graph it. That means that we just test the symmetry. So the first step, insert the r negative theta in the equation, and let's see if the new equation equals the old one. So r is r squared equals 16 times cosine. So right now I can't replace the negative theta. I need to use negative alpha because here is alpha. Use alpha. Negative 2 alpha. So cosine is even. That means equals 16 cosine alpha. Cosine 2 alpha. 2 alpha. So they are the same. So yes, it's symmetric to polar axis. And then second test, let's see, r pi minus alpha. So r squared equals 16 cosine. So 2 is outside. Better have this. 2 outside. And alpha place is replaced by pi minus theta, pi minus theta, minus alpha. We always make this mistake. So 16 times cosine. I can distribute the 2 inside. This 2 pi minus 2 alpha. So do you still remember if in the expression we have 2 pi that for the cosine, that's 1 period. That means add nothing. So I can get rid of the 2 pi here. 16 times cosine negative 2 alpha. So this is even equals 16 cosine 2 alpha. Are they the same? This one and this one? Yes, it's the same. So I can say symmetric to theta equals pi over 2. The third one is that symmetric to the pole. I can plug in negative r theta. So negative r squared equals 16 cosine 2 alpha. So negative r squared is still r squared equals 16 cosine 2 alpha. So it's still the original equation. That means symmetric to the pole. So it's symmetric to this one, and this one. So we test the 3 symmetry. Okay, next one, test the symmetry, this one. So we also need to plug in these 3. So first one, we plug in R minus, this is theta, that's negative theta. So R equals 3/4 times, so plus sine negative theta. So sine is an odd function. So 3/4 minus sine theta. Because it's odd function, I can pull out the negative sign in front. So it's not equals to the original one. So 3/4 plus sine theta. So here the conclusion must be inconclusive. I can't say it's not symmetric to the polar axis. I must say inconclusive to prove it's symmetric to polar axis. So the second one, R pi minus alpha equals 3/4 plus sine pi minus alpha equals 3/4. So do I need to prove this one equals sine alpha? Or you want me prove it's okay? Because we have learned that if this is alpha, and then this one is from here to here is pi minus alpha, and this one is alpha, reference angle is alpha. So the sine alpha equals sine pi minus alpha, or you just use the formula, you expand it. So sine pi cosine alpha minus cosine pi sine alpha. Sorry, it's on the top, 4 plus what? So sine pi is 0. So this term is 0. Minus cosine pi is -1. So that means +1 plus sine alpha. So this one equals this one. So it's symmetric to theta equals pi/2. And the third one, test -r theta. So if I plug it in, that's -r equals 3 times 4 plus sine theta. So this equation is not this equation. They are not the same. So inconclusive. You can't say it's not symmetric to the pole. You must say inconclusive. Okay, here is some special shapes of the graph. So if I have theta equals 0, that means theta is as angle is 0. That means I just have a horizontal line, this, and I don't care about the r. R can be positive 1, 2, 3, 4, or infinity, or negative infinity. So whatever the r is, the theta is always equals 0. The angle is also always 0. So this vertical line is theta equals pi/2, because the angle is from here to here is pi/2, and r can be any number. So the accumulation of the point for r make a line, vertical line. So another one, line through origin. So the theta equals pi/4. This is a line we mentioned about this. So if theta equals another number, if I say pi/6 or pi/3, that's a line like this, or any number for example, theta equals 2. So what is 2? Is so 2 here is an angle. That means 2 is the angle in the radian form. So here is pi is 3.14, and this is the half of 3.14. It's about 1.7 something. So 2 is about a line like this. Okay, this one, r equals a over sine theta, is a horizontal line, and the intersection here is the a, y equals a. So remember, if in the bottom is sine theta, it's this horizontal line like this, and the intersection depends on the a, on the numerator. This vertical line is the a over cosine theta, and then the intersection here equals a. It all depends on the a. If a is negative, so I have a vertical line here, and this intersection is the negative a's value. Okay, sine is the same. This one is the same. If a is negative, the line is under the polar axis is here. Okay, circle and spiral. If r is a, that means the r from here to here, from here to here is a. For example, r is 3. It doesn't mention about the theta, so any theta should be good. So that's a circle. And also another kind of circle is r equals a times cosine theta. We learned this one before. We solved this kind of question before. So this point is a, and the center should be absolute value of a over 2. Oh, sorry. For this one, a is positive. Here is a over 2, and the radius is absolute value of a over 2. And this one is sine. So for the cosine, the center is on the polar axis. For r equals a times sine, the center lies on the theta equals pi over 2 is lying on here. So a is positive, so it's on the top. A is negative, is in the bottom. And the radius is absolute value of a over 2. If r equals a theta, it's a spiral. What's the meaning of that? So if a is positive, so theta, for example, is pi over 3 or pi over 6. Sorry, pi over 6. So from here to here, pi over 6, and then we increase the theta's value. That means it's going counterclockwise, because this is theta. We're going counterclockwise for the positive value. And then theta is increasing, r is increasing. So it's going this way, all the way around. So that's a spiral. Okay, let's see the limmason. I'm not sure I have time. I better to stop. I will record another one, but let me talk a little bit about limmason. Limmason's form is r equals a plus or minus b times cosine theta, or r equals a plus or minus b times sine theta. The limmason's shape is like this, and this. And for example, r equals 1 plus 2 cosine theta. So a is 1 and b is 2. So if the b is greater than a, the shape is like this. That's just like you have a suction cup, and then you suck from this side. For example, you give the power or give the pressure for this one. You just pull it and pull this shape. Pull this shape to this side. And then if B is bigger, you give more strength. B is bigger than 1 because you put more strength on the suction cup. So you will make a inner loop because B is greater than 1. If A equals B, 1, 1 here. So you don't have that strength. So this inner loop go a little bit outside. Then there's no inner loop for A equals B. So that's a hard shape. We call it cardioid. And then if you have less strength, so you can't pull that hard. That means B is smaller than A, or I can say A is greater than B, but less than 2B. We call this shape is dimple limousin. So you see this hard shape, this point is going to here because I didn't give that enough power to suck it, so it comes to here. That means there's A is between B and 2B. So now A is much more than B. That means A is greater than or equal to 2B. So I can't give that too much pressure to pull the suction cup. That means my dimple come to here and there is no dimple and there's nothing concave, so we make a convex limousin like this because I have a very small number here, big number here, so my shape is like this. So actually we won't learn too much on this part because we will learn these kind of things, limousins, in pre-calculus. So I just mentioned about how I memorize these 4 kind of shape by thinking about the suction cups. Okay, let's continue. I think I don't have time, so let's stop and I will make another video later. And